All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be talking about refraction of light. All right, in previous video, we talked about reflection. So if you have not watched our video on reflection, the link is on the description. All right, now what is refraction? Refraction of light is defined as the process whereby a ray of light changes direction due to a change in its speed as it passes through one medium to another of different density. You see, what causes refraction is when there is a difference in density is what causes refraction. When a light passes through a two medium of different density, what happens? Refraction occurs, right? So then I say it is also defined as the bending of a light at the interface where it travels from one medium to another at an angle, right? If I have this, okay, this is an interface, this is my interface, and I have my normal, this is my normal. Let me say that here is air, and then here is what? Water. If you look at this, water and air have different density, okay? Water is denser than air, all right? Or you say that air is less dense than water, all right? Okay, now if I pass light here, let me decide to pass light to this part now. I have my incident rail, this is my incident rail. Then I'm going to have my reflected rail at this point. This is my R, and then still know that the light is moving this way. That is what is causing our what is it called? Refraction. Okay, our refraction. This is the refracted ray. This is the refracted angle. This one is the incident ray. Incident ray. Okay, but this one is called the incidence angle. Please know the difference. This is incident rail. Why this one is called what? Incidence angle. Why this is my normal. Okay, this angle here is my incidence angle. This one is my normal, the normal. Okay, then I have my, this one is what? The, okay, this is the refracted rail. Why this is called the refracted index, refracted angle, sorry, refracted angle, right? Or angle of refraction. Now, that is that. And you should know that what? In a media, that incidence rail is always greater than what? Than refracted rail. Sorry, incident angle. Sorry, the incident angle is always greater than what? Reflected angle whenever the light passes from a less dense medium to a more dense medium, right? This light come from the smaller one to the bigger one, okay? Then we now have that what? Then we now have that that the angle of incidence is greater than the angle of refraction, okay? But look at this case now. If we have this case, when I have that here is now the water, here is water, and here is air. Now, see what happened. The incidence, let's say that it is now coming from here. It's coming from here, okay? It will come from here, sorry. Let's say it will come from here, and then it will come from here. Now, this is my incidence, and this is my what? Refracted ray, refracted angle. So here, I will be less than R. Why? Because the media is coming from a higher denser or a denser medium to the less dense medium. So please, you have to take note of that. Please note it. They say note, right? Note number one. If a ray of light travels from a less dense a less optical denser medium, that is a medium that is less dense. Let's say, for example, air. Okay, it travels from air to a more optical denser medium, let's say water. We say that the ray of light is reflected in such a way that it bends towards the normal. You see, look at it. I have something like this. This one is coming like this, right? And this is air, and this is what? Water. I want to show you something. Now, this thing is coming to this way, and we know that water is smaller, is less dense than what than sorry, air is less dense than water. What happened? The refraction will go closer to this normal. Okay, it will go closer to this line of the normal. That is what will make it small. Okay, and hereby I will now be greater than what? R. But look at what happened in the other case. Look at what happened in this case. In this case now, let's say that here is now my water, okay, and here is now my air. This is air. I know that air is more dense than water. Then we now have that what? If the incidence is coming this way, this one will now move away. It will be moving away from the normal. It will move away from the normal. Okay, so that is where we have that I here will now be less than R. These are two most important things to note. Very, very important. Okay. So that is that. Now another one you need to note, number 3, that you need to note. Number 1 is that if it is moving from a less, if the incidence rail is coming from the less dense, okay, the refraction rail will be moving closer to the normal. Please write it down. If the incident rail is coming from a less dense medium to the higher dense medium or a denser medium, the refraction rail, okay, will be moving towards the normal. But if it is coming from a higher one, that is a denser medium to a less dense, it will now be moving away from the normal. Okay, that is first thing to note. Now another thing you need to note is that when you now have this, when you now have the incident ray passing through the normal, okay, it's going through the normal, the reflected ray also continues in that direction. And in this part, this is I and this is R. If you see that there is no angle there now, there is no angle. So we say that what? Our I will be equal to what? Our R, and it will be equal to 0. That's another thing you need to know. If it is coming perpendicular to the interface, if it is coming on that normal, okay, if it is coming directly perpendicular to the interface, then the line of reflection goes on the same way. Okay, so that is that. Now the next thing we are going to talk about is the law of refraction. The law of refraction. The laws of refraction. Now the first one states that what? That both the incident rail, the normal, and the reflected rail and the point of incidence, they call this point the point of incidence, all lie on the same plane called the interface. Please listen again. Let me say this is what? The incident rail, the normal, and what? And the refraction rail or refracted rail, okay, all lies on the same plane at the point of incidence. Please, that's one of the law. It's very, very simple. If you look at the diagram, you will remember how to state it. You tell them that what? The incident rail, the refracted rail, and the normal at the point of incidence all lies on the same plane called the interface. All right, that is that. So the second law say that what? That the sine of the angle of incidence, the ratio of the sine of the angle of incidence to the sine of the angle of refraction must be a constant. Okay, and we call that second law the Snell's law. We call it the Snell's law as well. So the second law of refraction is called the Snell's law. The Snell's what? Law. Okay, it is called the Snell's law. And this Snell's law is the Snell's law was discovered in the year 1621. They will ask you that. Snell's law is discovered by a man called Wilbrod Snell. His name is what? Wilbrod Snell. Sometimes they call it Snellus. Okay, that is his name. So that is why from his second name, he got that law. Okay, he named the law after his second name. So Snell's law states that what? That the sine of incidence to the ratio of the sine of incidence to the sine of refraction must be a constant. Okay, and we call that constant refractive index. We call it what? Refractive index. Okay, we call it refractive index. Please note that. Very, very important. Now, another thing you need to know is that the Snell's law can be verified using a glass block or optical pin method or a ray box method. They can ask you, what are the methods we use in verifying Snell's law? You tell them that we use what? Glass block method, or you say we use what? Optical method, or we say we use what? A ray box method. Ray box method. Okay, so that is that. So now let's go to the graph of the Snell's law. So this is the Snell's law. If they say Snell's law, you can just write this. This is the statement mathematically, that the ratio, division means ratio of the sine of the incident ray to the what? To the sine of the refracted ray is a constant. Very, very simple to state. And this Snell's law is equally called the second law of what? Refraction. The second law of refraction. Now let's talk about the graph. The graph of the Snell's law. The graph of the Snell's law. The graph of the Snell's law is what? Is a straight line graph that passes from the what? From the origin. When you have that the vertical axis, you plot sine I there, at the horizontal axis, you plot sine R there, and then you now see that this is your slope. This is change. This side is what? Change in sine R. This is change in sine I. Okay, we will now see that the slope of the Snell's law, or the slope of what? Sine I over sine R, okay, is equal to what? That constant. And what's that constant? We call it refractive index. We call that constant refractive index. Okay, they say that the Snell's law, okay, this is the graphical representation of the Snell's law. Now let us do something. If we decide to cross multiply, I'm going to have that what? My sine I is equal to what? N sine R. Okay, n sine R. Let me say plus 0. The reason I added 0 is because I want it to look like an equation of a straight line, because this is a straight line. Equation of a straight line said that y is equal to what? Mx plus what? C. What does it mean? It means that what? Y, that sine I is plotted along the y-axis, and the sine R is plotted along the what? X-axis. You know that my M here is the slope. So my slope is what? That's n. And what is my n? This n is called what? Refractive index. Why my intersection is 0? Intersection is the line where is the point where the line of best fit meets the horizontal axis, on the y-axis, sorry. And the only place they met was what? At 0. So you see that the intercept is what? Is 0. Okay, so now let's move to refractive index. Let's see what refractive index is. Though we have already said it, but let us just elaborate on it more. Refractive index. Refractive index. All right. Now in plural, I have it as what? Indices. The plural of index is what? Indices. Now let us do something. Watch me now. I have two medium like this. This is the first medium, medium 1 and medium 2. I have two mediums like this, okay? And then I have that my incident ray comes like this, and my refracted ray comes like this, and it's coming this way. So this is my I, and this is my R, okay? Now, something is going to happen. For this particular medium, we know that what? That sine I over what? Sine R is equal to what? Our n. Let me call it, this n is coming from 1 to 2. Okay? This n is coming from 1 to 2. Very, very important. That is that is the refractive index when it is coming from what? From medium 1 to medium 2. Now let us interchange the medium. Let's interchange the medium. Let's say that I have that here is medium 2, and I have that this is medium 1, okay? And then I still have the same thing again. This one is coming this way, and this one is coming this way. I have that this is my I, and this is my R, and they are still coming like this. Now, what happened? You will know that this is what? That the sine of I over what? The sine of R is equal to what? My n is equal to my n, okay? And this my n is what? When it passes from 2 to 1, okay? When it passes from 2 to 1. Now, something is going to happen here. Or let me do it in a way that you understand better. Wait, let us use the same medium again. Let's say that here is 1 and here is 2. Sorry, I want to show you something. Here is 2. Okay, but this is my now I want to use the same thing. I want to use the same thing here. But this time around, we are passing the light from this way. It's moving from this way to this way. Okay. Then it's going to be uh, your what is it called? Your refractive index is always the sign of where it is coming from. So this is coming from R. So it's coming from R to I. I want to show you something. There's something I want to derive. It's coming from what? R now to I. Okay. That is what? The refractive index from 2 to 1. Now, let us do something now. Watch me now. Watch this now. This my sign R over what? My sign I is equal to what? Now, if I want this thing to turn around, if I want it to come here, here will come here. I'm going to be 1 over. So 1 over sine I over what? Sine R. Okay? The inverse of this thing will still give me back this thing. So, and you see that this is equal to what? 1 over sine I over sine R gave us what? Gave us this 1 to 2. Refractive index of 1 to 2, which is what? The refractive index from 1 to 2. Now, but I know that this one normally means the refractive index from 2 to 1 is equal to what? 1 over the refractive index from 1 to 2. Okay? So this is an important formula to know, but let me write it very well. This one, they can change position. Tell them that what? The refractive index from medium 1 to 2 is equal to 1 over the refractive index from medium 2 to 1. Very important formula to note. We'll use it in calculation, please. Very, very important. Okay? That is that. Now, we're going to solve some calculations so that you will understand what I'm trying to say. Now, okay, let me just give you just a playful example. If they say that the refractive index from air to water is 3, what is the refractive index from water to air? What do you do? Turn it over upside down. It's going to be 1 over 3. I get what I'm saying. If they say the refractive index from air to water is maybe 3 over 2, what is now the refractive index from water to air? So it's going to be what? Turn it upside down, 2 over 3. Okay? Note that. It's very, very important. You are going to use it very well in calculations. So let us solve the first question. The first question we are going to solve here said, number 1, they say a ray of light striking a transparent material is refracted, okay, refracted as shown below, okay, as shown below. Then I say calculate I, the refractive index from 1 to 2, then I, the refractive index from 2 to 1. And then they gave us a picture like this. They say that this one is this is 75, while this one is 40, is 47. And then I say that here is medium 1, and here is medium 2. All right? Now, this is very, very simple. Don't forget your Snell's law. So for me to get I, for me to get N, okay, let me solve it here. I, for me to get refractive index from 1 to 2 is what? The sine of what? 75 all over what? Because it's coming this way, okay? And still moving this way. So the sine 45 divided by what? The sine of what? 47. So which will give you what? Which will give you, so sine 45, sine 75 will give you 0.9659 all over this one. Sine 47 will give us 0.7314. Okay, so if you now do it, you're going to have 0.9659 divided by 0.7 divided by 0.7314. I'm having 1.3206. Okay, now look at this. So for us to get the II now is what? The refractive index now, when it is now coming from 2 to 1, means the sine of it is now coming from 2. So the sine of 47 divided by what? The sine of 75, which is what? 0.7314 over what? 0.9659. Or simply, I will just say 1 divided by this answer I've gotten. You will still get the same answer. Okay? If I say 1 divided by this answer I've gotten, I'm going to get 0.7572. Okay, so you see that is a very, very simple question to calculate. We go to the next question. Question number 2. So question number 2 said calculate the angle of refraction. Calculate the angle of refraction of a ray of light from air striking an air glass interface. Then I say making an angle 60 degrees with the interface. Okay, and then I say we should take the refractive index from air to glass as 1.5. Okay, solution. This is very, very simple. Now let us draw it and see what they are telling us to do. Now I have that here is my air and here is my water. Okay, and I have that this is my refractive the incident rail, and then this is my refracted rail. And then they say that what? That calculate the angle of refraction. Okay, this is what they are asking us. The angle of refraction, let me call it my R. Okay, and then I said that what? That it is making an angle of 60 degrees with the interface. Please, very, very important that the incident rail is making an angle of 60 degrees with what? With the interface, and not with the normal. This is the interface, 60 degrees. All right, so for me to get my I, don't forget that here is your I. So for you to get your I, you know that from here to here is what? Is 90 degrees. So I will tell them that what? That's 60. So my I, that if I add 60 plus my I, that I'm going to get 90 degrees. That is perpendicular angle. Okay, the reason is what? Perpendicular angle. So my I is going to be what? 90 minus 60, which is what? 30 degrees. Immediately I've gotten my I will tell them that what? That my incident from my A, the air to glass, is equal to sine I over what? Sine what? R. And they gave me this one as 1.5. So therefore 1.5 is equal to what? Sine 30 over what? Sine R. Okay, so what do we do now? What do we do? Let me just finish it up here. I will now have that my sine R is equal to what? Sine 30 divided by 1.5. Okay, so therefore my sine R is equal to 0.5 divided by 1.5. So therefore my sine R is equal to 0.5 divided by 1.5. I'm going to have 1 over 3. And 1 over 3 is 1 over 3. So therefore my R will now be what? My sine inverse of what? 1 over 3. So what do we have? Sine inverse of 1 over 3. Shift sine answer. So I'm going to have 19.5 degrees. Now please, anytime you are getting an angle, make sure that your angle is just in 1 decimal place, because that is the only thing we can calculate with a protractor. Okay, so it must be in only 1 decimal place. Please note that is very, very important. You shouldn't put your angle more than 1 decimal place. Okay, so we move to the next one, except the option has more than 1 decimal place. Maybe it's an objective question and they decide to put more than 1 decimal place, then you can use it. But if not, just always keep your own in 1 decimal place. All right. So question number three said use the information in the figure below to calculate a incident refracted index from A to W, B, theta. Okay, then they say that I have that this is my air and this is my water. Okay, and I have that here, they say that here is 48, and then here they say that here is 60, and then they say number 2 here, they gave me this one. I say that here is water and here is air. Okay, and then I say that here is 20 and then here is theta. All right, so let us now solve the solution. Now, if you look at this, you see that automatically I can get my I and my R here. So my R is simply 90 minus 48, because my incident rail is my incident angle is the angle the incident rail makes with the normal. Please, they may ask you to define it. My incident angle is the angle the incident rail makes with the normal. Okay, and not the one it makes with the interface. No, it is the one it makes with the normal. Okay, so my I here is going to be 90 minus 48. So what do I have? 42. So I have 42 here. So my refracted angle R, don't mind my tongue, please. My refracted angle R is what? The angle the refracted ray makes with the normal. So it's going to be 90 minus 60, which is what? 30. All right. So therefore, a question. They say I should calculate what? My N of what? A W. That is from air to water, which is what? The sine of what? Incident, which is 42, divided by what? The sine of what? Refraction, which is what? 30. So if you do that, you're going to have sine 42, okay, divided by sine 30. I'm going to have 1.33, okay, 1.3383, 1.3383 as my answer. All right. So now, if you look at this now, let's calculate our B. Our B now, they say we should get our theta. For us to get our theta, if you look at the picture of number 2 here, you will see that they interchange it now. Okay, this is coming like this, please. Very important to know where it is coming from. Okay. Now, they now interchange it and now put water up and put this one down. It is very simple. You will tell them that what? The refracted inverse, the refracted index of air and water that I'm looking for now, from water to air, should be 1 over that of air to water, which is what? Which is going to give me what? What am I saying? It's going to give me 1 over 1.3383. Okay? Having gotten that, we should now know, we are going to know that what? My refracted index, okay, let me get the answer. The answer is going to be 1 divided by this, my answer. I'm going to have 0.7472. 0.7472. Okay, this is from water to air, should be equal to what? Sine 20, this one, divided by sine theta. So therefore, my sine theta will now be what? Sine 20 divided by my W of A, which I have gotten. So sine 20 divided by 0.7472. So therefore, sine theta is equal to, let's do that, sine 20 divided by my answer. So I'm having 0.4577. So theta will now be sine inverse of this my answer. Okay, so shift sign my last answer. Shift sign my last answer. I'm getting 27.2 degrees. 27.2 degrees is a very simple thing to calculate. We go to the next question. Question number 4. Right? Question number 4. So question number 4 here said, use the information below to determine a question. They say the refractive index from air to glass. Okay, they say we should correct to 2 decimal places. Question number B, they say the angle marked P. Okay, the angle marked P, and then this is my diagram. They say that here is glass and here is air. Hope you know that air is less dense than glass. You should note that. They gave me that here is 70 while here is 40, and it is going like this. Please, this arrow that I'm drawing is very, very important. The arrow drawn is very, very important. The arrow will show you where it is moving. Please. Then it will not help you in your calculation. So the next one they drew is now from glass again and air. They now say that this one is like this, and here is your P. This one is like this, and then that here is 60. Okay, now this is very, very simple. They say we should calculate the refractive index from air to water. So refractive index from air to glass. From air to glass is what? The sine of what? 40 is moving like this from air to glass. So sine 40 over what? Sine, somebody will say 70. Please, it's not 70. Rather, I need to get here. Here will not be 30. How did I get 30? 20. 20. How did I get 20? 90 minus 70. So it's supposed to be 90 minus 70. Okay, which will give you sine 40 over what? Sine 20, which will give you what? Sine 40 divided by sine 20. I'm having 1.8. All right. So now, to calculate the second one, which is very, very simple, you will now look at how it is coming. Now, this time around, it is now coming from glass to air. Don't forget that here will be your 30. How? 90 minus this 30. We don't use the one with the horizontal. We use the one with the normal, which is the vertical. Okay? We should tell them that what? The refractive index from what? From glass now to air should be what? Sine of angle in the side of glass, which is P, over what? Sine of angle in the side of air, which is 30. But to get this one is 1 over this one. Don't forget. Please don't forget that what? That your ng of A should be what? 1 over NA of G, okay, which is equal to what? 1 over 1.88, which will give you 1 divided by my answer. I'm going to get 0.5320. Okay, so I'm going to use 0.5320 is equal to sine P over what? Sine 30, 0.5. So therefore, my sine P is now what? 0.5 times 0.5320. So therefore, sine P will be equal to, so times 0.5. You now have 0.2660. So my P will now be what? Sine inverse of 0.2660. So I'm going to have shift sine my answer. I'm going to have 15.4 degrees. 15.4 degrees is the correct answer. All right, so we move to the next thing. So the next thing we're going to talk about is now the refractive index in velocity. Okay, in terms of velocity, refractive index in terms of velocity. Refractive index in terms of velocity. Okay. Refractive index in terms of velocity. Can I clean here? Yes. So let's talk of refractive index in terms of velocity. Okay. Now, they say that what? The absolute, now let's define absolute interference. Okay. They say absolute absolute refractive index. Sorry. They said absolute refractive index of a medium is the refractive index of a rail traveling from vacuum to the medium. Okay. It is what? It is the refractive index of a ray traveling from vacuum. A vacuum is a place, it's a space where there is no air at all, nothing is there. Okay. You should know that. So you should know that absolute means one. The word absolute means one. So if they ask you absolute refractive index, okay, absolute refractive index is what? Is it should be 1 over, or but let me just show you the formula normally. It is what? Velocity of light. Velocity of light in a vacuum. Okay. And the velocity of light in a vacuum is always 1, please. Okay. In a vacuum divided by velocity of light in a material or in a medium. Okay. In a material, any material at all, material. So please note this, very very important. Now let us get but if we want to get, if we remove this absolute, now we want to get refractive index. Normal formula for refractive index, you know, is sine I over sine R. But another one I need to know in terms of velocity is velocity of light. Velocity of light in air. And velocity of light in air is always is 1.00028. Okay, it's almost the same thing with this. That is why we normally use the one for vacuum, because the 0.00028 is as good as negligible. Okay. But you should know, just know this formula, that is velocity of light in air divided by the velocity of light in what? In that material. Okay. In that material. Okay. Since you have known this, another thing you should know, please note that, very very important, note that refractive index is inversely proportional to the sine of the angle it makes. Okay. It is inversely proportional to the sine of the angle. Okay. Please note this, is very very important. Now if we remove proportionality sign, we see that what? Refractive index is equal to what? K. If I bring down proportionality constant, K over what? Sine theta. Okay. If I cross multiply, I will see that my K is equal to what? N sine theta, which show that what? N1 sine theta 1 is equal to what? N2 sine theta 2. Very very important formula to note. N1 sine theta 1 is equal to N2 sine theta 2. Please note this formula. Note these two formulas. Very, very important to note. Can I clean? Yes. Let us now solve calculations to illustrate what we have already said. So question number one said, given that the refracted index given that the refracted index of diamond the refracted index of sorry yes given that the refracted index of diamond is 2.42 and the velocity, okay, they say given that the refractive index of diamond is 2.42, they now say sorry full stop, they now say calculate the velocity calculate the velocity of light in diamond. Okay, calculate the velocity of light in what? In diamond. Okay, solution. Now this is very, very simple. We know that what the refractive index is equal to what? The speed of light, that is velocity of light in air over velocity of light in that material. What is the material here? Diamond. Okay, diamond. And they gave us this one as what? 2.42. They said that the refracted index of diamond is this. So 2.42 is equal to, please, there is a constant you need to know. Velocity or speed of light in air. Speed of light in air is always 3.0 times 10 raised to power 8. They will not give it to you meter per second. They will never give it to you. You should know it. So 3.8 times 10 raised, 3.0 times 10 raised to power 8 is the velocity of light. Now divided by what? Let me call this velocity of what? Diamond. So if I cross multiply that, I will have that velocity of diamond is simply 3.0 times 10 raised to power what? 8 divided by 2.42. If you do that, you are going to get your result. So I have 3.8 times 3.0 times 10 raised to power 8, then divided by 2.42. So I'm having approximately 1.24 times 10 raised to power, I think times 10 raised to power the same 8. Let's say 3 divided by 2.42. Yes, 1.24 times 10 raised to power what? 8. All right. That is a very simple question. We go to question number 2. And question number 2 here said, given that the velocity of light what am I saying? Given that the velocity of light in water, okay, is 2.26 times 10 raised to power 8 meter per second, and in glass 2.0 times 10 raised to power 8 meter per second. They now say calculate the angle theta below. Calculate the angle theta below. And then I have this. They now drew this. They said that here is what? 30 degrees. And here is theta. And it is coming this way. And then I have that here is my glass. and then here is my medium. My what? What am I drawing? Sorry, this is water and glass. Here is water. Water and glass. Okay? So they gave me let me see the question very well. Okay. Okay. So I have that the velocity. What am I saying? Okay. Now having this, you should know that my refractive index of water to glass should be velocity of what? Velocity of light in that water over what? According to where it is coming from, over the one in glass. Okay. If I have this, I'm going to have what? This is equal to what? Which one is water? Okay, I have 2.26 times 10 raised to power 8 divided by what? 2.0 times 10 raised to power 8. So 10 raised to power 8, take care of 10 raised to power 8. I'm going to have 2.26 divided by 2.0. So I'm having 1.13. Okay, so 1.13 is the refractive index. So now to get this angle according to the way it is coming, you will see that what? That refractive index from water to glass is equal to the sine of what? Theta over what? Sine 30. So this one is what? 1.13 is equal to what? Sine theta over what? Sine 30 is 0.5 over 0.5. So if I cross multiply, I'm going to have that. Let me finish it up here. I'm going to have that sine theta is equal to what? 1.13 times 0.5. So therefore, sine theta is equal to times 0.5. I'm having 0.565. So my theta is going to be sine inverse of 0.565. So I'm having that my theta shifts sine my answer. I'm going to have 34.4 degrees. So 34.4 degrees is the correct answer to that question. So we move to the next question. Question number 3 here. So question number 3. And question number 3 said that if the refractive index of glass is 3.2, we should calculate the refractive index of the medium in the figure below. Okay, they gave us the figure. They said that here is my glass and here is the medium. Okay, they now gave us angles. They said that here is 30 and here is 60, and then okay. So solution. Now you should know that they gave us the what? If the refractive index of glass, so n of glass is equal to 3/2, they gave us, and I know that the theta of glass is equal to 60 degrees. Okay, and they gave us the theta of the medium is what? 30 degrees. So we are now need to find the what? The refractive index of the medium, which is unknown. So don't forget that what? Ng of the same sine theta g is equal to what? Nm of what? Sine theta m. This thing is gotten from where I said that n1 sine theta 1 is equal to n2 sine theta 2. Don't forget this formula. I gave it to you before. So let us now do it. So I have 3 over 2 times sine 60 is equal to what? My n of m sine 30. So if I cross multiply, I'm going to have that my n of m is equal to 3 over 2 sine 60 divided by what? Sine 30. So if you do that, you are going to have 3 sine 3 3 sine 60 divided by 2 sine 30. I'm having 2.5980. Okay, 81. Okay, so that is that for question number 3. So we go to question number 4. Oh, it's not easy. So move to question number 4. So question number 4 said a ray of light is incidented on a water glass interface as shown below. Then I say calculate the value of angle R. Then I say you should take refractive index of glass of water as 3 over 2. Okay, glass and water 3 over 2 and 4 over 3 respectively. Okay, respectively. So the diagram they gave us here, they gave us water. So they drew this thing like this. As shown below, they gave us that here is 30 coming this way, and then they say that here is R, and they say that here is water, and then glass. Okay, so solution is very, very simple. So what do? We go again. We know that our n of glass they gave us is 3 over 2, and n of water they gave us is 4 over 3. So and then theta of water they gave us as 30, while theta of glass they gave us as R. So you should know that what your n of glass sine theta of that same glass is equal to n of water sine theta of that water. So if you now do that, you're going to have that 3 over 2 times sine R, okay, because this is R, is equal to what? 4 over 3 sine 30. So therefore my sine R will now be 4 sine 30 over 3 now times 2 over 3, because it's going to be divided by this. So if you change divide to times, they will now swap. Okay, so it's going to be what? So I'm going to have that. Let me finish it up here. I'm going to have that sine R is equal to, let me do everything once. I'm going to have 4 times 2. 4 times 2. Okay, sorry, 4 sine 30. Okay, divided by 2. Sorry, divided by 9. Then times 2. That is 4 over 9. So 4 over 9 is the answer. So 4 over 9. So therefore my R will now be sine inverse of 4 over 9. So which is what? Shift sign answer. I'm having 26.4 26.4 degrees. Okay, 26.4 degrees is the result. So let me check my time. I've really gone very far. Okay, so let me continue. So the next thing we are going to talk about now, is all right. Okay. The next thing we are going to talk about, let me just draw this thing for, for this question. Okay. So next thing we are going to talk about is what? Refractive. Okay, refraction. Refraction, refraction through successive medium, through successive media. Okay. Now I now have let me have three lines like this. Okay. And then I have the first point here. This is air. This is medium 2. Medium 1 is air. This is medium 1. Let's say medium 1. But let's say that it is air. Okay. Then medium 2 can be anything. Then medium 3. Then we now land in air again. Medium 3. Okay. So I now have that this comes this way. All right. Then I have that here is my I, and my here, sorry, here is my what? My R1, R1 that brought about R2, R2 that brought about our I again. Okay. So from this thing, you should note, please note that the refractive index from 1 to 4, from 1 to 4, okay, just know this formula, is the refractive index from 1 to 2 times the refractive index from 2 to 3 times the refractive index from 3 to 4 times the refractive index from 5 to 6, like that. That's how it goes. So this is it for that. So if you want to do for just 2, the refractive index from 1 to 3 should be what? The refractive index from 1 to 2 times the refractive index from 2 to 3. Very simple. So in conclusion, the refractive index from 1 to maybe k, any number, is equal to what? The refractive index from 1 to 2 times the refractive index from 2 to 3 times the refractive index from 3 to 4, dot, dot, dot. It continues till what? Till the refractive index from k minus 1, from k minus 1 to k minus 1 to k. Okay. All this is I'm writing does not really concern you. All you need to know is just that, just from here you should know what it means. If it's to 10, that's how you keep going till the 10th one. Okay. It's very, very simple. So let us solve calculation to illustrate that. Calculation time is a blessing time. So let us solve calculation and be blessed. So question number one said the refractive index, of water, is 4/3, and that of glass is 3/2. Then I say calculate the refractive index of glass with respect to water. Okay, with respect to water. Solution. Wow. So they gave us the refractive index of water. Now, please, if they say the refractive index of water, know that it is coming from air to water. So I'm going to say that what? The refractive index from A to water, from air to water, they gave me is 4/3. And then I say, and that of glass, that is from air to glass again. So the refractive index from air to glass is what? 3/2. Then I say, what is the refractive index of glass with respect to water? Now, with respect to water is coming from, whenever you hear with respect to, know that the first one mentioned should be the last person. Know that the refractive index from glass to water means that it is coming from water to glass. Please note that. They say calculate the refractive index of glass with respect to water. If you hear the word with respect to, then this is where you are going backward. That means it is coming from water to glass. So which means we want to calculate the refractive index from what? From water to glass, because I saw with respect to. Okay? Now, if you look at this, you will see that the middleman here is what? Is my air. Everybody goes to air. So air is the middleman. So since the middleman is air, this means I'm going to say the refractive index from the first one from water to that air. Okay? Then from that air to my what? To my glass. From water, maybe you stop at air. Let me say that somewhere here is air, like that. Then from that air, you get to water. So from water to air, then from air to water. Okay? So now, since I have that from air to water is 3/4, what do you think that from water to air should be? If you can remember, I told you that the refractive index from 1 to 2, if it is 5/4, then if you now change from 2 to 1, they will turn around. It's going to be 4/5. I told you that before, that from 1 to 2 is 1 over from 2 to 1. Don't forget. So I have that from air to water is 4/3. Then from water to air should be 1/4/3. That is what? Turn it upside down. That is 3/4 times, this one is already the way it is, that is 3/2. So if you do that, you're going to get 9/8. So 9/8 is the correct answer there, right? So question number 2. You see, this is very, very simple. So question number 2. So question number 2, right? Question number 2 said calculate the angle theta below, comma, given that the refractive indices, the plural indices of glass and water are 3/2 and 4/3 respectively. Okay? So what do we do now? We're going to have that okay, they now give us a diagram. They give us a diagram. They say that that here is water. This is water and glass. Okay? Then I say that here is 30 and then here is theta. Okay. I'm going to try to use two formulas to solve this and know if we are going to get the same answer. Let us use the normal formula that I've been teaching you now. So solution, if you use normal formula, I thought that once they say the one of glass is this, so you should know that it is coming from air to glass. Okay, that from air to glass is 3/2, and then I gave us that from glass, what am I saying? That from air again to glass is what? 4/3. So then I say we should now calculate theta. But before we calculate theta, we need to get from water to glass, since it is coming this way. Let me check the way it is coming from my this thing, so that I will not make mistake. Okay. Okay, yes, it's coming that way. Okay, so now having this, for me to go from water to glass should be from water, watch you, from water to air dot from air to glass. Okay, so we have from water to air. Sorry, they say that the glass and water, sorry, this is water, not glass again. Okay, they say that from air to water is 4/3. Therefore, from water to air should now be what? 3/4. Okay, times, then from air to glass they gave me as 3/2. So if you do that, I'm having 9/8. Okay, this is it. Now, but you should know that what? That the refractive index from water to glass is equal to what? The sine of 30, the one of water, all over what? The sine of theta, which is the one of glass. So I've gotten this one to be 9/8 is equal to what? Sine 30 divided by what? Sine theta. So if you permit me to finish it here, I'm going to have that what? That sine theta will now be what? 8 sine 30 divided by 9. So I'm going to have, that is 4/9. So 8 sine 30 divided by 9. I'm going to have, so that is 4/9. So my theta will now be what? Sine inverse of 4/9. So sine inverse of 4/9, shift sine my answer. So which is giving me 26.4 degrees. 26.4 degrees. Now, alternatively, let's solve this thing this way. They gave us what? That n of glass is 3/4, and n of water is what? Is 4/3. And then they gave us that theta of water is what? Is 30. Then theta of glass is now my problem. So my problem is theta of glass. Do you remember a formula that said that n of g sine theta of that same g is equal to what? N of water sine theta of water. Let's do this and see what is going to happen. Okay, so n of g gave us 3/4 sine, sorry, theta of g. Yes, okay. So sine theta of g is equal to what? 4/3 sine 30. Let us do this and see what we are going to have. Now, this one will go up, this one will come down. So this is what? Sine theta of g is equal to 4/3 sine 30 times, it's going to be 4/3, because it's supposed to be divided by 3/4. So if you change divide to times, it will turn to 4/3. So I'm having that sine theta g is equal to what? This time, this, everything here will give me, do it, you're going to have 4/9. So therefore, theta of g will now be what? Sine inverse of what? 4/9, which is the same thing we got as 26.4 degrees. So any way you like, you solve it, you will still get the same result. Okay, you will still going to get the same result. So let's go to the next question. For the next question, right? Question number what now? Okay, question number 3. So question number 3 here said, question number 3 said calculate the angle theta below, given that the refractive indices of glass to water are 3/4, so 3/2 and 4/3 respectively. Okay, so you can pause the video and try this. Okay, let me draw it first. So the diagram they gave us is this way. They say that this one is that here is 60 degrees, and this is going this way, and then here is the theta they say we should calculate, and then they say that here is water and here is glass. Okay, you can pause the video and then try to solve it yourself, okay, before you come to my solution. Now we are going to solve it in two ways again. So let's say that they told us the one for glass first, glass and water, and okay, or glass to water, anyone. But we know that glass goes to 3 over 2. So we say that n of from air to glass is 3 over 2. And then n from air to water is what? 4 over 3. Okay? Then I say we should get uh, n of water to glass. So they say we should calculate, oh, they say calculate the angle. Okay, from water to glass is what we want to get, from water to glass. So from water to glass means from water, air is the middleman. So we say from water to air times from air to glass. Okay, times from air to glass. So I'm going to have water to air. If air to water is 4 over 3, water to air will now be 3 over 4 times this one is normal, 3 over 2, which will give me 9 over 8. All right. Now you should know again that the formula for refractive index from water to glass is what? The sine of that water divided by the sine of the glass. But the sine of the glass here, don't make mistake, it's not 60. It's going to be what? 30. 60 minus this. 90 minus the 60. So 90 minus 60. Because this one is with the horizontal. We need the one with the normal. Okay? Please don't forget that. So if I put this, I'm going to have 9 over 8 is equal to what? Sine 30. Sorry. Sine theta over what? Sine 30. So therefore, my sine theta will now be 9 sine 30 divided by 8. So therefore, my sine theta will now be what? So 9 sine 30, okay, divided by 8. So I have 9 over 16. So therefore, my theta will now be sine inverse of what? 9 over 16, which is going to give me shift sine 9 over 16. So I'm having 34.2 degrees. So this is very, very simple. Now let me use the other method to solve it. If I use the other method to solve it, I'm going to tell them that what? They gave me that n of water to be what? N of water is the second one, which is 4 over 3. And n of glass they gave me is what? 3 over 2. But they gave me theta of water as theta. Why they gave me theta of glass as 30? This one not 60. That is 90 minus 60. Okay, which is what? 30. Okay, you should know that n of water times sine theta of the same water is equal to what? N of glass times sine theta of the same glass. Okay, so what do we have now? I'm going to have n of water is 4 over 3 times what? Sine theta is equal to what? This one gave me 3 over 4. Sorry, 3 over 2. Sorry, 3 over 2 sine 30. So if you cross multiply, you are going to have that sine theta is equal to 3 over 2 sine 30 times 3 over 4. Okay, so if you do everything, you are going to get your result, which is the same thing we got. So you are going to get that what? That sine theta will now be equal to, if you do everything here, you're going to get 9 over 16. Sorry, 9 over 8, right? How did I get 9 over 6? Okay, yes, this is 1 over 2. 3 over 4 times 1 over 2 times 3 over 4 will give you 9 over 16. So 9 over 16. So my theta will now be what? Sine inverse of 9 over 16, which is what? 34.2. So you see, any method you like, use. It's very, very simple to solve. So we'll move to the next question. Question number, we'll go to the next thing, and which is, I think, the second to the last thing we're going to do here. So the next thing we're going to talk about is about the real and apparent. The real and apparent depth. Now, the real and apparent depth. Okay. Now let's have a glass of water. Let's have a glass of water like this. Let's have a glass of water like this. Okay. And then I now place uh, maybe a coin inside this place. Now, if you look at this coin from here, you will see that this coin will appear to be somewhere closer. It doesn't appear at the same place. It sometimes appears to be somewhere closer. Okay. So if it appears to be somewhere closer, I'm going to have that. Let's draw this like this. I have this. Okay. Okay. So now the length from here to here is the real image or the real depth. From here to here, okay, is the real depth. This is the real depth. Okay. But from here, from where the thing is, that is, let me say, from here, from where it is, from here to here, is what we call the apparent. It appears to, from the word appear, you know that it is what? Apparent depth. Apparent depth. Okay. Now here is now the difference between them, and we call this difference between them the what? Vertical displacement. We call it vertical displacement. So so vertical displacement is simply the difference between them. Okay. So vertical displacement is now the difference between the real depth minus the apparent depth. Okay. This is very, very simple. So let us now solve some questions to illustrate what we have just learned so far. Okay. So you have known what is apparent depth, where it seems to appear when you look at it from water. Okay. When the ray of light passes through the water, the way it appears, like if you put something inside the water and look at it, where it appears to be, you will be seeing it as if it is closer, but it is down, something like that. Okay. Why the what? The vertical displacement. From the word displacement, you know that displacement is distance. Distance means where you stopped minus where you started. So you should know that it is the difference between the real and the apparent. And the word apparent means appear to, where it appears to. That's not the real one. It is where it what? It appears to be. Okay. So question number one. Question number one said a coin in a glass jar filled with water appears, you see, they are not telling us the apparent, appears to be 24 cm, appears to be 24 cm from the surface of the water. Calculate the height of the water. The height of the water is the real depth. The height of the water in the jar. The height of the water in the jar, given that refractive index, given that refractive index of water is 4/3. Okay. Given that the refractive index of water is 4/3. All right. Now, oh, I forgot to tell you something. Please, you should know that what? Please note, before you write this question, know that refractive index is equal to what? The height, that is the real depth all over the apparent depth. Please note that it is the real depth over what? The apparent depth. Please, very important, okay? So let us now do the solution. This is a very simple question to solve. So if you know this formula I've written there, you will tell them that refractive index is equal to what? The real depth over what? The apparent. So what do we have? They gave us that the refractive index is 4/3 is equal to the real depth is the height of the water. So the height of the water is the real depth h all over what? They gave us the apparent depth, which is what? 24 cm. So if their own is in cm, your answer should be in cm. But if it's an objective question and their own is in meters, then you know that you just need to convert to meters. So if I cross multiply, I'm going to have that my h is equal to what? 4 times 24 divided by 3. So what do you have? We're going to have 4 times 24 divided by 3. So I'm having 32 cm. 32 cm. Now, they can decide to ask you the vertical displacement. The vertical displacement, I told you, is just the difference. So the vertical displacement is equal to what? The real depth minus what? The apparent depth. So what do we have? The real depth is now the height of this, which is what? 32 minus the apparent depth, which is what? 24. So if you subtract, you're going to have minus 24. I'm having 8. So 8 cm is what? The vertical displacement. That's the vertical displacement. So we'll go to question number 2. So question number 2 said a glass of block of thickness. A glass of block of thickness 12 cm is placed on a mark drawn on a plain paper. Then I said the mark is viewed normally through the glass. Okay, then I say calculate the apparent depth of the mark, and hence the vertical displacement. Then I say that the refractive index of glass is equal to what? 3/2. Okay, so very simple solution. We know that the refractive index is equal to what? The real depth over what? The apparent depth. So apparent depth. So now that is what? 3/2 is the glass. They say that a glass of block blah 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 is marked. So the thickness of that glass is the real height. That is what? 12 all over the apparent depth. So therefore the apparent depth is simply 12 times 2 divided by 3, which will give you 4 times 3, 8 cm. Okay, say 8 cm is the apparent depth. So from here we can calculate the displacement. The vertical displacement is equal to what? The real depth minus the apparent depth, which is what? 12 minus 8, which is what? 4 cm. Very, very simple to calculate. So we'll now talk about we're almost through. Let's talk about the graph of real depth to apparent depth. Okay, the graph of real to apparent depth. The graph of the real and the real to apparent depth. Okay, so now having this is very, very simple. So what do we do? The graph is just a straight line graph. Okay, so it's just a straight line graph that passes through the center, while the vertical side is the real depth. Okay, while the horizontal is the apparent depth. Okay, so it's a straight line graph that passes through. So this, the change in the real depth over the change in the apparent depth, is now the slope. So the slope is the what? Change in the real depth over what? Change in the what? The apparent depth, which we know as what? Our refractive index. All right. So, which means we have gotten so much formula for refractive index. I'm going to list all of them down for you. Okay. So, let me just list all of them down for you, and then we move to the next thing we have. And then the next thing we have from here, we have that, well, first of all, we found out that refractive index is what? Sine I over what? Sine R. We know this. And we still know that it is what? The velocity, the velocity of what? Velocity of blah blah blah. Just list all of them down. Let me look for it. Velocity of light in air, velocity of light in air all over velocity of light in that medium. Okay, we still see that it is equally the real depth over what? The apparent depth. Okay, we equally see that it is equal to what? What else did we find out? So, and so on and so forth, for the ones I couldn't remember. So you can go through the notes that you have written to find other formulas of it. Okay. So now let's move to the next thing. And the next thing we have, which is the last thing I'm going to talk about here, is the total internal refraction. Total internal refraction. Total internal refraction. Okay. So now, so when you're talking about internal, that is, it happened in the same media. It happened in the same media. Now let's talk about a critical angle. Okay, they say that a critical angle is the angle of what? Incidence. Is an angle of incidence in the denser medium, for which the angle of refraction in the less medium is at right angle. What am I saying? If I have this, look at this, I have this, and this is let me say that this is water, and then this is air, or let me say, okay, let me say that this is air, and this is water. Okay, I now have that a ray of light came from this side. It came from here. Okay, it came from here. It came from the one that is high dense to the less dense. But what happened? Instead of it to refract like this, the refractive the refractive ray goes at an angle of 90 degrees. It goes perpendicular. Okay, it goes perpendicular to the normal. It goes perpendicular to the normal. Instead of having an angle, it goes perpendicular to the normal. So this angle made here, this incident angle made here, is now called your critical angle. It is called the critical angle. So critical angle is the angle, the incident ray, okay, of a light that passes through the denser to the least dense, that makes the refractive ray to be at right angle to the normal. Okay, so find a way to write your own definition. But from what I just explained now, you will know what I'm trying to talk about. So the next thing we're talking about is now the internal um, refraction. Internal refraction is when I have another one. Let me have another ray of light coming this way. Okay, now instead of this thing to reflect this way, it bounce back to the same medium. Once it bounce back to the same media, and I have that this is my R here, while from here to here is my I. This is what we know, that is what is known as what? Internal refraction. Instead of reflecting outside, it came back to the media. It didn't go to that, the less dense media. So that is what we called the internal what? Refraction. All right? So let's look at conditions for internal refraction. Number one, the ray of light must be traveling from a more dense medium to a what? To a less dense medium. All right, please, very very important. It must be traveling from a more dense medium to a less dense medium. Then number two, that the angle of incidence must be greater than the angle of what? It must be greater than the critical angle. And if you look at it here, you see that the incident angle is greater than what? Than the critical angle. So that is that. Now let's look at the relationship between the critical angle and the refractive index. Relationship between critical angle and the refractive index. Okay, relationship relationship between critical angle and the refractive index. Right, now let's look at this, the same thing we did before. Let's have something like this, and then I have that this is my, this is air, and this is water. Let me use air and water, and it's coming this way. This is my C, and then this is my what is it called? This is my okay, in the same medium. So it's going to be like this. Sorry, it's going to be like this. Sorry. So correct the other one, because it's in the same medium. It doesn't go outside the medium. It is in the same medium, please. So this is my R. Okay. Now having this, we know that my this, you know the meaning of this? Incident, incident what? What's it called? Reflective index. Sorry, reflective index is equal to what? Sine I over what? Sine R. Okay, so I have that my this is equal to what? Sine the critical angle, because my I here is the critical angle, all over my R here is what? 90. So sine 90, and sine 90 is 1, which shows that what? The refractive index is equal to what? The sine of the critical angle. Please note that. That is very very important to note. Okay, sorry, that's a mistake, please. That's a mistake. Sorry, it's supposed to be your n is equal to sine. Where is it coming from? It's coming from here. So sine C, right? Yes, sine this is n of, yes, I'm correct, n from water to air. Let's use it like this. From water to air is equal to what? Sine 90 degrees. All right, so which is what? N of water to air. Okay, let me call it R. Okay, like I did before, is correct. From water to air is equal to what? Sine C over what? Sine 90. And sine 90 is 1. So therefore, my N of water to air is equal to what? Sine C. Very, very important. But you should know that, but normally, my refractive index N supposed to be from the smaller one to the bigger one. So from air now to water is my normal refractive index. So it's going to be 1 over that of from water to air, which is equal to what? 1 over sine C. So therefore, my refractive index is equal to what? 1 over what? Sine C. Very, very important formula to note. Okay? So we're going to solve 1 or 2 questions, and then we are done for today's class. So I'm going to solve just 2 questions, and then I'm done. The first question I'm going to solve here said number 1 said the critical angle for water is 48.6 degrees. Then I say calculate the refractive index of water. Refractive index of water. solution. You know that if they say refractive index of water, you know that it comes from air to water. Okay, so I know that refractive index is equal to what? 1 over sine what? C, which is what? 1 over sine 48, which is what? 48.6. So which will give you 1 divided by sine 48.6. So I'm having 1.3, 1.33, okay, as my answer. So the last question I'm going to solve, question number 2, and then I'm done for this particular video. Question number 2 said that I should calculate, okay, they said a ray of light, travel travels through air into a medium as shown below. Okay, then I say calculate the critical angle, of the medium. Then I drew something like this. Then I say that here is 60, and then this is air, and this is the medium, and then they now say that here is what? Is 25.7. Okay, so getting the critical angle is very simple. The first thing I need to get is my n. My n is what? Sine 60 over what? Sine 50, sine 25.7. Okay, so which is going to be what? Which is going to be sine 60 divided by sine 25.7. I'm having 1.9970. Okay, but I know that my my n is equal to what? 1 over sine critical angle. So therefore my sine critical angle is equal to 1 over n. So my sine critical angle is what? 1 over 1.9970. So my sine critical angle is equal to 1 divided by that, 1 divided by my answer. I'm having 0.500, 0.5007. So if you do that, you're going to have that my critical angle is going to be the sine inverse of that answer. Sine inverse of that answer. So permit me to write it in. So my critical angle is going to be what? The sine inverse of that 0.5007. So I'm having shift sine answer. So I'm having 30.0 degrees. So thank you very much for watching. Please don't forget to like, share, and subscribe if today is your first day of watching my video. Bye bye.